Hey guys, welcome back again to our next lesson. Today we're going to be studying how to find equations for lines. Our mindset message today is that mistakes are important. You know, a lot of this algebra stuff is just a little bit challenging and sometimes we make mistakes, but remember, your brain learns from mistakes. In fact, that's the best way your brain learns often. So keep that in mind. Learning goals for today, there's just one main learning goal. We need to be able to write an equation for a line based on the slope formula. And we're going to remind ourselves of that. Prior knowledge, just plotting points is something we want to remember how to do, and then finding the slope, but specifically finding it using the slope formula. And if you remember, the slope formula says if we have 2 points, x1, y1, and then another one, x2, y2, then in order to find the slope, rise over run, it's the difference in y coordinates over the difference in x coordinates. So let's jump in and take a look at this lesson. There's a little bit of thinking I want to do with you to start off here. Let's just suppose I have a random point in the plane somewhere. Let's say this is on a coordinate plane. How many lines pass through this point? Well, you probably can realize that there's an infinite number of lines that could go through this point, right? You could draw any line you want with whatever slope you want, so long as it passes through that point, right? But what if instead I had 2 randomly chosen points? Exactly how many lines pass through both points at once? And remember, when we say line, we mean straight line, okay? Well, when you think about this for a moment, you can probably realize if you have 2 points, there's only one straight line that goes through 2 points. So our important fact to start here is 2 points guarantee a unique line. If we have 2 points, you know there's only one line that goes through them. What that means for us is, if we know 2 points, then we must be able to find an equation for that line. There's got to be a way to do it, and that's what we're going to spend our time doing for today. Another thing to add on here is, what if we only know 1 point, but if we do know the slope, we can just find the second point. So let's say I have another random point here, and maybe I know the slope is -1 over 4. So that means my rise is -1 and my run is 4. Well, if I know that slope, I know if I go down 1 and over 4, there must be another point. And guess what? We can just go back to saying, okay, now I know 2 points, so I'm able to find an equation. Well, now let's jump in and learn how to get an equation with this. So we're going to dive right into an example first, but review this time. So here's a line through 2 points, and use the slope formula to find its slope. Now, a lot of us are visual, so it helps. I do have these points and the line that goes through them plotted here on this graph. But why don't you go ahead and use the slope formula and do the work yourself, and we'll check it, and then we'll go into figuring out an equation for this line. Okay, so let's go ahead and check. So remember, if we just subtract the y's and subtract the x's, and the difference in y over the difference in x. So -2 minus 4, -3 minus 1. Now, just so you know, remember, we could have started with this y and this x first, and we could have done 4 minus -2 and 1 minus -3. And in the end, we'd still get something that simplifies. If you simplify this out, it becomes 3 over 2. So -6 over -4, but the negatives cancel, and this simplifies, so it becomes 3 over 2. Now let's look here. On the graph, we can see, watch what happens. Every time I go up 3 units and over 2 units, rise over run, we get back on the line again. And in fact, anything in that ratio, even if it's 3 little squares to 2 there, or if I went up 6 over 4, that's how I literally get to here. And in fact, this -6 and -4, it will show its face here too, but that's like thinking backwards. If I went down 6 and left 4, you'll notice this ends up with the same result. So whether we say 3 over 2, or -6 over -4, or +6 over +4, those all represent the same slope as each other. So there's a little bit of slope review. Now let's actually get into finding an equation. Okay, I forgot to call that last part, part A, finding the slope. Now part B, write an equation for this line. Here's how we're going to approach this. Let's just imagine any other point on the line somewhere, okay? And we're just going to say, if I call any point on the line xy, okay? So in this case, xy represents any other point. I could have placed this anywhere along that line, okay? And here's the cool thing that we're going to do with it. We're going to use the slope formula between this point xy and this point or this point. It doesn't really matter. And since we know the slope, we can leave the xy in there, and then we've got an equation that has an x and a y. So here's what I mean. Here's the slope formula, essentially, right? Difference in y over difference in x. But I chose to use the point xy, some random point on the line, and I just chose the point 1, 4 that was already given to me here. And since we know the actual slope is 3 over 2, what this equals is going to be, we're going to actually put the numbers in there. So look, this is an equation involving an x and a y that represents this line. And the cool thing is, if I put a number here for x and another number here for y, as long as it makes it equal to 3 over 2, then we know those coordinates will be on the line. Okay, now that we have an equation, we can do what we've learned before. We can use this equation as a point tester. So let's actually find some x's and y's that make this equal to 3 over 2, and we can verify if it's on the line or not. So let's think this through together. The most obvious one, if I just want to get 3, well, what minus 4 is going to give me 3? Oh, well, that's easy. That's going to be 7, right? And then 2, what am I going to subtract 1 from to get 2? Oh, that means x would be 3. So it looks like 3, 7 is going to make this work. And let's check this. 3, 7, yep. It's right there. Let's do one more together. Now, you might think, well, Mr. Engel, isn't that the only way to get a 3 and a 2? Remember, a 3 over 2 ratio can actually be a lot of different things, okay? 3 over 2 could also be 6 over 4, or it could be 9 over 6, even if we wanted. Why don't we try to get 9 over 6, because that's still equivalent to 3 over 2, right? So let's go back here. Remember, this is my y and my x. What do I subtract 4 from to get 9? I think that's 13. And then to get 6, I think it would be 7 down there. Ugly 7. So it seems like if x is 7 and y is 13, then the point 7, 13 should also be on the line. So if you were to go to 7, I don't have enough to go to 13, but it would be up there at 13 and we'd be good. Why don't you find maybe 2 more of these yourself, and I'll make another list of different points also. So I found some more points, and I actually put them all on the line. They're pretty much visible with this segment of line that I wrote. 5, 10, or -1, -1, or -5, -5. Now, just remember, if you plug the y and the x in and calculate it, you'll see that it gets something that's equivalent to 3 over 2, and that means that all these points should be on the same line because they make this equation true. Now keep in mind that there's an infinite number of points that actually fit this equation, because you know that there's an infinite number of points that make up this line. But for now, we just want to get in the practice of searching for some of those, and the main thing that's important today is that we were able to write the equation for that line. Let's go get some practice on your own at doing this. Okay, here's 3 different practice problems. We've given you some information and you want to find an equation for the line based on that information. So this one we gave you the slope already and then 1 point, so we can just build that equation. So we'll do A together real quick. Remember that it's y minus the y coordinate over x minus the x coordinate equals the slope. So in this case equals -1/5. And then all we've got to do is figure out coordinates for a point that's going to make this equal -1/5. And there's lots of ways to do this. I can think of this as a -1 on top, and that would make the y coordinate need to be, I think 1 minus 2 would be -1, if I'm not mistaken, right? So if I put 1 in there, yeah. And then to make 5, what do I subtract 8 from? I think that's 13. So 13, 1 would be a point that must be also on this line, okay? So going back to this, let's put that back. So Same thing for part B. Now for part C, I give you 2 points, so you're going to need to find the slope yourself and then build the equation off of either one of those 2 points. Go ahead and do that for yourself now. Let's check your equation for part B. Y minus the y coordinate and then x minus the x coordinate. Now this minus a negative, I just wanted to mention to you, that just becomes a positive actually, so we can just make that y plus 2. Now you can use it to find a point. And another thing to remember is this 3 might be a little confusing, but don't forget that 3 is the same as 3 over 1, or you could even put it as 6 over 2 or anything that's equivalent to 3. So here's 5 different points I found that made this work, so you can check and see if it's one of those. You can also check your work by just putting this red equation into Desmos and then just seeing points on the line and then checking that they fit. For part C, as I said, you need to find the slope first, and if you actually do the rise over run, you get 14 over 4, or that simplifies to become 7 over 2, and let's look at the equation. So actually there's 2 different equations you could have written that would both be correct for this. You could build an equation off of this point or off of this point once you find the slope. So if I build off of 115, then I get this one. If I build off of negative 3,1, then I get this one. And in a later lesson, we'll actually learn how to show that these really are equivalent equations to each other, even though right now they actually look different because of those numbers being different. And again, let's check a few points on this line. I maybe will just use this top equation to find some points. And here are just 3 points that I found on this line. But again, once you found your point, or maybe you found a few points, you can just type this right into Desmos and you can check that those really are on the line. Well, that does it for this lesson today. It's not a super long one. So again, happy math, and we'll see you next lesson.